Welcome to the screencast on how to make up and use a rule to create a sequential pattern, use a rule to make a prediction, and describe rules for continuing number and spatial patterns. You'll notice that the word rules keeps appearing in each of these. And a rule is where we have a mathematical rule in place that must be followed in this particular sequence. So for instance, it might be in a number sequence like this, 1, 4, 7, 10. You can see in this sequence that each time we are having to add 3 to the next number. So in that case, the rule on this is 3. You'll notice that there are some other interesting words in here. This word prediction simply means to be able to guess with some authority what the next number in the sequence will be, and a sequence means a reoccurring pattern. So we're going to look at a number of examples of these, but if you just remember, the main word rule is where something has to be followed no matter what in the sequence. So let's take a look at one. In front of you here there are two number sequences. So if we do read this top one here, that will help you to decide what the next two numbers in the sequence are. Okay, in that first one there, the next two numbers are 2 and 4. And the reason is the rule in this pattern is there's reoccurring numbers. The sequence goes 1, 2, 2, 4, then 1, 2, 2, 4. So therefore the pattern must continue. The rule of this is that it goes 1, 2, 2, 4. Let's take a look at the second one here. In this one here, you'll actually notice that it's a similar type pattern. The answer is, just before it, is 8 and 10. The reason is it goes 8, 10, 12, 14, and then it repeats again, 8, 8, 10, 12, 14. So the pattern is to use those 5 numbers, keep repeating each and every time. So there are a couple of examples of patterns and where I've been able to use my ability to predict it. But the key thing is I must determine what the rule is. That's the most important thing. Let's take a look at another example. This one here, it gives me a slightly different pattern. And this time it's actually matchsticks, and Matthew found the number of matchsticks in each pattern like this. Multiply the pattern number by 2, then add 1. Is this true? So the question here is actually asking us to determine whether this here, which is the rule, whether it actually applies to this pattern. So let's take a look at the moment. This one here, what we can do first, rather than looking at whether it drawn pattern 5, 6 or 7, we can very quickly determine from the ones we already have here whether it's going to work or not. Multiply the pattern number by 2. Pattern number here in this case is 1, so I'm going to go 2 times 1, which is equal to 2, and then add 1 makes plus 1 equals 3. That works for that one. Let's have a look at for this one. 2 times 2 equals 4, plus 1 equals 5. Is it? 1, 2, 3, 4, 5. Looking pretty good. This one here, pattern number 3, and I'm going to do this one down here. So let's try that. 3 times 2, which is equal to 6, plus 1 equals 7. 1, 2, 3, 4, 5, 6, 7, and let's just check it out with this one here. Goes 4 times 2 equals 8, 8 plus 1 equals 9. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that rule is true. So if we were to do this out, pattern 5 would be 5 times 2 equals 10, plus 1 equals 11. So again, I've been able to use the rule as the basis for you to determine what the pattern is in the sequence, to be able to predict what future numbers or matchsticks will be in the pattern.